head, so I have to
Give them
on
to us?
Yeah.
Yeah, I'll give them to you. Because we got a lot of stuff to remember. You don't even remember that. Okay. And I also give you the Roman numerals too. I tell you what I'm not going to. Did I tell you all of those? Okay. Let's do the covalent names. Let's do tricarbon, hexa. Oh, no, not hexa. Yeah, let's do hexa. Hexa bromide. What is the formula?
C3, 6, no, F, no,
BR6.
BR6,
BR6, yeah.
Do
It's
you
pretty
have-
easy.
Would you mess us up on purpose so that we'd have to see if it's right? Like draw 6 bromides and.
Oh, after this, I could ask you another further question. I could say, draw the Lewis dot structure for this now. Oh man.
But what if it's wrong?
If it's wrong, then of course
Then
you
we
couldn't
have to-
draw it, could you?
Well, no, because we'd have to add another carbon or add another bromide. Would that, you know what I mean?
Well, if
Oh,
you
I
have-
could say, name this correctly or something like that.
Oh,
Yeah, like if you had 4 bromides and 3 carbons and it didn't
Yeah.
work out,
Yeah.
and you'd have to add like a carbon to make it.
I wouldn't ask a question like that because people would get way too confused with a question like
Yeah.
that. Okay, so it'll be
but
straight.
you would do the opposite, like formula to name.
Yeah, I can do the format to the name. So if I do something like this, instead if I do and notice I'm only giving 2 different elements. I'm not going to give you 3 different things and ask you to name it. I'm going to say, given this formula now, let's say, Cl8. What would the name be?
Diphosphide.
You got
Diphosphorus.
yes, diphosphorus, because it's just the full name.
Octochloride.
Yeah, octochloride. The second element gets the I. You alright? Okay. Just felt like clapping. Alright. So that's the naming. That's all the naming that we're going to have to do. Those are all the types of names. So if you can get these straight in your head, these are ionic, and this is covalent, and you don't confuse these two, then you're going to be set pretty well. Covalent's always the 2 nonmetals put together, or it's got a prefix. That's how you tell if it's going to be named like this, and over here the ionic is going to be a metal and a nonmetal, or you've got a transition metal and a nonmetal.
To make sure that the transition metal is inside here, right?
Yes, it's in the middle. It's pointing to the middle block. Okay. Let's go on to the next. Next is Lewis dots. The Lewis dot structures. I give you a formula, or I could be tricky and give you a name and say, draw the Lewis dot structure. All Lewis dot structures are for covalent bonds. They're always going to be covalent. There's no ionic for Lewis dots because they don't share electrons. They give electrons and take electrons. So let's do that. We did naming. Let's do Lewis dot. So Lewis dot, let's do an easy structure first. Let's do CCl4. Let's do Cl3H. Okay. What do you do to find the Lewis dot structure for this?
Carbon has 4.
Yeah, so you put carbon. Most of the time, carbon's going to be in the middle. If carbon's not in the middle, then it's going to be nitrogen in the middle. Okay? So carbon's in the middle, and it's got 4 dots. Spread those dots out as evenly as you possibly can.
Put Cl around, 3 of them,
3 Cls all around it.
and an H.
Cl, Cl, Cl.
And
Now,
an
what
H.
didn't I do?
You didn't put the dots.
Didn't put the dots. Do you need to put the dots?
Yeah.
Yes.
6 dots, right?
7.
Oh, 7?
Yeah. I'm doing like this. I do every side once. I come back around. 6, 7, and then 1. So the single dots are the ones that are important. Those are the ones that are going to be the bonding dots. So I'm just going to circle those in red. So all the red dots right now are going to somehow be connected. So I'll connect them. All the single dots, all the single dots. So how are we going to connect these? Easy. They all go to that center carbon somehow. Like that. Like that. Go like that. Right. Now this is the Lewis dot structure. But if you want to write this more correctly, you do it like this.
Would you need to
If I ask you for this, if I ask you to draw it more neatly, then you draw it like this.
Yeah,
Less neatly, like this. If I say draw this neatly, you draw it like this.
That's why I said 6, because like I was thinking it neatly.
Yeah. Oh yeah. Okay, I gotcha.
That's all I do is neat.
Just neat.
Yeah.
Plain neat. Gotcha. All right. So that's the Lewis dot structure. That's pretty easy. I hope. We can do lots of other kinds of questions like this. I can ask you a really complicated one like with lots of O's and H's, like C, O, O,
L.
H,
Is there an L?
and there's no L.
That'd be cool.
That would be cool, but there's not. So let's see. Let's put an N there. Let's put a. What else should we do? A C and an H. Holy crap! Can we solve this? Let's lay all the pieces out first. So this is an example of a really tough one.
2 H's.
We know we have 2 H's, yeah, so let's put the H's. I'm going to put them on opposite sides because that's what it looks like over here. Put single dots, put 2 C's. I'm going to try to arrange them like this because I think there's a reason.
A C.
So C, and then an N.
I forget on this part.
No.
C. 2 O's.
Let's put the O here. I'm running out of space. I'm going to put the O right there and an O right there. Okay. Now, if you want, this might help you to make these dots bigger. The single dots make them a little bit bigger, so that way you know what you need to connect. It's a little bit easier just to see what you need to connect. I hope I did this right. I might have done this wrong. I might have given you an impossible structure. Let's try it. Now let's connect them up. What do you want to connect?
H to C.
I did make it. Did I make it wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's do this.
If it was 8, cool. If it was, it has to be even number to work.
Yeah.
So you could bond the H to the C.
Okay, let's try that.
3 dots to C.
Let's do 3 dots.
I mean to the N to N. I mean.
But if we do that, then the end's going to be totally bonded here, and it can't bond anywhere else.
Oh, 2
One
dots.
O needs to go to a C.
Let's try this. Oh.
Now,
Now.
fit the both C's to N.
Both C's to an N,
Yeah.
like this.
No. Well, that sure. And then
Okay.
the other C to the N. Yeah. And then
C to the O.
no. Yeah.
Which O?
Yeah.
This one up here?
Yeah. And the last 2 to the
Ah, there we go. Now they can all connect. I'm sure that could work. I mean, it's a ring. That can work though. Yeah, you could do that. You might also do something like, I'm looking at it. That could work. That's one structure. All right, you can also draw it like this. Maybe this would work a little bit better. If you do. Yeah, that wouldn't work. That's fine. That works. So as long as you have an even number of dots, you can figure it out. Just connect the single dots. Right? There's no way that, I can make up any of those. I just totally made that up right there. You can make up any problem as long as they have even number of dots, they can work. Alright?
Yeah.
The single dots are the things you need to connect. What else? Well, that's Lewis dot. Let's talk about
So I'm
Pacific.
gonna give us the structure and then now let's figure out the thing you need.
The shape.
Setup. Like C and C O O 3.
CNCO.
I don't know.
Can you give an example?
You want to give us the
Of
structure?
a separ? I wouldn't give you the structure, I wouldn't give you the Lewis dot.
Right.
I'd say, figure out what the Lewis dot
Right,
structure is,
right.
then figure out the separ. Yeah.
You give another example of Lewis dot.
Sure. Let's try that. Let's say that I give you this example. I give you CH3, CH2, OH. Yeah, OH. Okay? And then I'd ask you a couple things, actually. I could ask you, this is exactly the same kind of format I use in the test. In fact, let me make sure it's absolutely clear. I got the test right here.
Oh, yeah.
Yeah. Okay. So I'd ask you the molecular geometry first. Oh man, that's the separ. Then I'd ask you the bond angle. And then I'd ask you, is it polar? We didn't have that over here, but that's nice. Is it polar?
But that's an IMF.
That's an IMF.
And is it what is its IMF? Okay? So those are the things I would ask you for this one single formula. I'd say, first draw the Lewis dot structure, then tell me all that stuff. Okay? So let's draw the Lewis dot structure first.
So since it's a C
Yeah?
and 3 H's, I one on top of the
Okay,
side.
so we can go a little bit faster now. Let's just assume that they're bonded like that.
Another C,
Yeah?
bond
Yeah.
to that C, and this
Yeah, HH.
HH,
Oh,
so
top, bottom.
top and bottom, okay. Sure.
O,
about
and then O, and then H on the other side of it.
On the other side of
it
it?
has two
Yeah,
lone pairs.
and then
Oh, wait. But
Yeah.
let's always draw oxygen bent like that. Because that's what its molecular geometry actually is it's bent.
You can have
Two
each.
lone pairs.
Well, why can't you have?
You could draw it the other way, but that's leading you down the wrong thinking.
Yeah.
If you put the H out over here, then it looks like that's linear. It's
Oh,
not really
as
linear.
the polar or the IMF.
Yeah, I'm just saying, get into the habit of making this bent when you're drawing out the Lewis dot structure, because that way it doesn't lead you down the wrong path. Okay, so this is the Lewis dot structure. You get full credit for that. Now, what's the molecular geometry? Let's say around this
O.
O, and that's the one I'm always interested in.
That's
Yeah,
They
that
have
one.
109.5?
Yeah, this is going to be bent at 109.5 degrees. Oh, that's the bond angle, 109.5 degrees. Alright, is it polar?
Yes.
Yes, how do you know that?
Because they all go to H. I mean, O.
Yeah,
Oh,
everything's being
most
pulled
Oh,
towards that oxygen.
no.
And there's nothing else that's counterbalancing this and being pulled towards oxygen over there equally. So overall, this is going to be a polar molecule. And what's its IMF? Intermolecular force.
Since it's polar, it will be
This polar.
H bond. H bond.
Yeah.
Ah, very good. So if it's polar, it can be two things. It can either be dipole-dipole, or it can be dipole-dipole,
Called H bond.
or it can be the H bond. And here we've got OH, which is one of the kinds of H bonds. So it's definitely going to be an H bond. Good. Right. And you get 100% correct answer if you do that, all that stuff right there.
That's a question right there.
That's a question exactly like how it's going to be like on the test. So you can get a whole bunch of these Lewis dot structures and just go through those examples, and you can tell yourself if they're bent or whatever geometry they are. You'll get that sheet, that chart on the exam, that same chart that you used on the quiz. So you got that chart, and you can tell me what kind of geometry it is, and if it's polar, then after that, and what kind of IMF it is. Okay?
Yeah.
How's that arm tasting? Good?
Yep.
Alright, good. That's
That's where.
kind of it. Well, Vesper, the separ, that's you. If you look at any of these molecules or any of these atoms right here, we've got three different choices. Okay. If I bold one of these in the formula, that's the one I want you to focus on, and you tell me what the shape is around that. The shape being the molecular geometry. We just did that, but let's see if we can do this one. Right, the separ. What's the shape around that? We've got tetrahedral around that, and what about this one?
Tetrahedral.
Tetrahedral, yeah. Both of them are going to be tetrahedral.
120, right?
109.5 tetrahedral.
Not Polish.